Hi, welcome to our video demo. I'll be walking through our application and explaining each page and its functionalities. We're currently on the home page. It displays a welcome message. If we go to the About page, it gives an introduction of what our application does, and it talks about the technologies we use. We use front-end React, Material UI, Express, Node.js, SQL, MongoDB as backend. We also display sample data we use for this application from Rotten Tomato and IMDb. There are 4 tables in total, and each query fetches real-time for 5 sample tuples so people can understand what data and attributes we're using. So for stats page, it provides some statistics for user to better choose movies, and it is also the page where we display our complex queries. For the top 10 most reviewed, we aggregated over review. For average ratings by genre, we aggregated over genre and created index for optimization on ratings. Previously, it ran over 2 minutes, but is now roughly 17 seconds. For a movie with greatest difference in rating, we optimized also by creating an index on review. Previously, it ran 36 seconds, and now it runs roughly 22 seconds. We also have top 10 by top critics, which we also optimized by creating an index. Previously, it ran roughly 2 minutes, but now around 30 seconds. We also have top 10 favorite languages by region. For this one, instead of using indexing, we used caching to store subqueries and caches, and pre-optimization it ran 55 seconds, post-optimization roughly 100 milliseconds. So for search page, we can actually search based on user input. For example, if you want to fetch all movie that has title keyword Harry in both database and select language English, the page will run a simple query to search by the criteria you specified. Lastly, we have a user profile page. It displays user's profile pic, username, and search history. For example, we just searched Harry, where language is English, and it appears over here. This page actually uses MongoDB, where all user-related information is stored in the MongoDB database. Although we do not have a login page, there are other users. So I manually switched a user, and now everything is related to test user instead of Alice. If we now search Harry Potter from Rotten Tomato, it'll show here in its search history. And this is all our functionalities and pages. Thank you for watching.
This is the stats page of our web app where we showcase 5 of the queries that we've written. You'll notice that even some of our simpler queries take a while to run simply because our dataset is so large. For example, Title Actus has over 1 million data entries in it. This unedited clip is roughly 55 seconds long, and now we're going to briefly go over what optimizations we made to make some of our more complex queries run faster. The favorite language query gets movies in their most popular language. On screen, you can see the pre-optimization and post-optimization queries. To optimize this query, we use the caching method, as indicated by the creation of the region language ratings cache you can see in the post-optimization query. This effectively cut down our runtime from 55 seconds to 100 milliseconds. The reviewed movies query gets all movies that meet certain review criteria. To optimize this query, we take our 2 subqueries which check for different review conditions and combine them into one subquery, combined critic review, in our post-optimization query. We also calculate necessary counts and filters before joining in our post-optimization query, reducing the runtime from 20 seconds to about 3.5 seconds. The rating difference query gets all movies with polar ratings. Below you can see the pre-optimization and post-optimization explain plans for both queries. This query was optimized by first removing the redundant Rotten table, and second by creating an index on average rating in the IMDb ratings table, decreasing the runtime from 36 seconds to 22 seconds.